As promised, isomers. Isomers differ in how they are bonded. Or in the bonding sequence. And there's a few of them. There's constitutional isomers, sometimes just known as structural isomers. An example would be if I had something to C4H10. As an example, I'm going to draw them out this way. So this is C4H10. This is also C4H10. This is butane. This is 2-methyl propane. These are structural or constitutional isomers. They have the same formulas. They do have different densities. They do have different freezing points, melting points, boiling points, etc. So if we did C5H12, there's 5 and there should be 12 hydrogen. This is pentane. Just we'll get used to naming some compounds. So now I guess I didn't need the dash there. This is now 2-methyl butane, but it is still C5H12. There is one more. Two-dimethyl propane. These are structural isomers of C5H12. Pretty cool. By the way, this one has the highest boiling point because it has the strongest London forces. It's kind of somewhat linear. This is more of a sphere, so it's going to have the lowest boiling point. and the weakest of the London forces. Another set of isomers, stereoisomers. One form of stereoisomers is geometric isomers. With these, there's always going to be a double bond. So the first one that we encounter with this is C4H8. And versus, since that double bond cannot rotate, so this top one is known as trans. In fact, it's trans 2-butene. This bottom one here is known as cis 2-butene. These are geometrical isomers. They're only different because of the geometries around the double bond. I'm going to put one more up here that's also C4H8. I guess I should draw it in two-dimensional. This is 1-butene. 1-butene is a constitutional isomer. Or we can say a structural isomer of 2-butene. Pretty cool stuff. There are a couple more, and I will save them for a later date. They're around chapter 4, chapter 5.